in 24 hours. How? Thanks to modern technology, 3D printing. On-site. This is the world's first actually printed house. Construction 3D printing opens a new round of evolution thanks to the innovative design of the printer. It consists of a mobile construction 3D printer and automatic mix and supply unit, which combine to make the construction printing process as much automated as possible and almost eliminate the human factor. This equipment is unique and has no analogs in the world today. Ease of transport and maximum automation of the system. Commissioning on site takes no more than an hour. With so many advantages, the 3D printing technology easily accounted for competition with traditional methods of construction. The testing was successful and the technology is ready for mass use. Application of the concrete mixture that is used as the ink is possible at temperatures from 5 degrees Celsius above zero. The equipment can operate at temperatures as low as minus 35 degrees Celsius. Time of printing amounted to 24 hours. Soon, using new materials such as geopolymer concrete, houses could be printed in both summer and winter. In the printing process, we used horizontal fiberglass reinforcements for the walls. The quality of the printed wall surface allows to perform final finishing immediately, which significantly reduces the cost of finishing works. It used loose dry insulating material on one part of the house and polyurethane composition on the other. Technology does not require fixtures. On the inside, the printed house is no different from a regular concrete house. The house interior includes a hall, a bathroom, a living room, and a compact functional kitchen with the most modern appliances. The house size is 38 square meters. Construction costs amounted to $10,134, which corresponds to approximately $275 per square meter. And this, in view of the shape complexity of the building. Prices include all works and materials for the construction of foundation, roof, exterior and interior finishing works, installation of heat insulation of walls, windows, floors, and ceilings. A regular square house made using materials of an average price category would cost about $223 per square meter. Construction 3D printer allows to save up to 70% on erecting buildings boxes compared to traditional material and labor-intensive construction methods. Are confident that this house was the first step which convinced the world that 3D technology on the market today is a reality. 3D printers enter the global market and construction sites worldwide.
The home is heated by an in-floor radiant heating system.
Took to building a 3D printer, just like anyone would, and with that, he spit out layers upon layers of concrete to build this 12-foot tall castle. As Bill Hudson explains, it's just a small example of things to come.
Was a contractor with a passion for computers and architecture and a mind for invention. Captivated by 3D printers, Ray designed his own. He built an extruder that spits out layers of concrete in whatever pattern he programs.
Like a regular printer, but much bigger size.
To extrude the concrete, he had to get the mix just right. After the layered walls of the castle were complete, pieces of the turrets were printed out and stacked into place. And he's dreaming even bigger, scaling up the size to, yes, build something to live in.
It's not just some days. I can print house like in a couple months.
This is getting a lot of attention from a lot of interested parties, including, get this, folks at Disney. The Magic Kingdom could well benefit from his 3D extruding technology.
This is a 15-second overview. We're going to be talking about 3D printing across scales, from printing buildings to printing with metal and looking at different materials to mobile systems, printing with... So I had this idea, what if we could just print the mold? Could we print the mold and then pour in concrete? And if we make the mold out of something like thermally insulating foam, you could leave it in place because it would basically insulate your building. So this same concept has been shown in commercial scale through the use of insulated concrete formwork, ICFs. And this has been growing for about the last 20 years in popularity. And they basically, when you make a foundation, you can stack these like Lego bricks, put in a rebar, and then pour in your concrete. So these are commercially available. And I wanted to see, could we actually use that concept but 3D print it? So we can have control over the geometry, we can have control over the width, the thickness. And the nice thing about this is if we can do this, we can use all the techniques, all the code certification that's associated with ICFs for our structures. We don't have to worry about freeze and thaw cycles with layer-based adhesion. We don't have to worry about finishing techniques. So I started looking at this and started doing prints with our arm. I explored a variety of polyurethane foams and explored a variety of techniques. So here you can see that it could drive over things that it had printed. So this was the idea going forward. Could it actually drive on things that it had already made? Added rebar ties, so it could be just like commercial systems. To stick simple to start with, we should print a dome as the first structure. A dome is one of the most structural stable things that you can make. So this was the kind of rough shape that we were aiming for, and we ended up doing the large-scale print. So here it is on its own. So here's the first layer of the print, and you can see we're basically using the KUKA for the small movements, and then the boom arm for the larger movements. And it actually had a fabrication print time of 13.5 hours. And you can see that we've also added in some little rebar ties as well, just like the traditional ones. So it took us 2 days of fabrication time because we didn't work all night, but the actual machine print time is 13.5 hours, which is really, really exciting for us to see. And one of the neat things about the foam is it actually expands 40 times volumetrically. So by taking a small amount of material to the site, you can actually make things much, much larger than the footprint of the system. And then at the very end, you'll see it is able to self-drive out here and back into the garage. So that's actually think it's potentially the world's largest on-site continuous 3D print by mobile system, which is really great. And one of the neat things about it is we actually think that it would be code certifiable if we went down that path, because you could basically fill it as if it was an insulated concrete form. So this was the resulting structure. It was basically a 50-foot diameter dome with an open top. And that's meter scale. And you can see it's really large. And one of the neat things of standing inside it was the echoes all come right back to the center. So we could take a speaker, put it anywhere in there, and you couldn't tell where the speaker was. It was absolutely incredible. And to show that we can actually do full horizontal printing, meaning we could close the dome if we wanted to, we basically are able to vary the nozzle angle, and we could show that we could print straight horizontally out. So this is kind of a bench that we made, and you can see that we can actually print completely horizontally, which was great to see. We also did comparisons to traditional construction techniques and showed that we can go much faster, be a lot safer, and actually come in at a much lower cost. This is a process record for the digital construction platform. So lots of different. So this was the initial design for it. It's all based around a track-based unit, and Altec also mentioned we could be the first to install an experimental electric drive system on it. So we could make it a hybrid. We can make it electric and diesel. So lots of different dimensions listed here: maximum reach, maximum speed, power, all of these things, right? The exciting thing is that we now have a tool. We now have a platform that works. So in the future, we can do all these amazing things. So in the future directions, I did some rendering to show what could happen with some of the early concepts developed here on the large scale. And this is what really kind of excites me, is thinking about how could this change the world in the future.
Balance and grace. You may be dreaming of a home that can withstand natural disasters and save you money. Whatever you long for in a dream home can be achieved. Innate strength, cost effectiveness, and endless design possibilities create an inner beauty as well. Shape and simple construction process that keeps the home affordable. A dome is a superior structure built at conventional prices. Domes typically require about half as much energy to heat and cool when compared to conventional structures. These savings are achieved by using what we call the dome's thermal battery.
We've been swamped with requests from people all over the world, so I'm
The walls of this house were printed entirely on site. This is the world's first actually printed house.